So a little bit forward into the waves. We talked about wave refraction. Now we're going to talk about wave reflection, which is just like a mirror. So waves and wave energy can be bounced back from a barrier. So if you have either a man-made barrier in the path of a wave, or the beach is right in the path of a wave that's coming in, wave energy can actually get reflected. And some complicated human activities, like here in Newport, California, the harbor is built in such a way that the waves coming in, the waves that are getting reflected from these structures because of a combination of the wave crest approaching here, hitting the jetty and getting reflected off the jetty, and the reflected waves meeting the wave that is coming in after the reflected wave. So it creates this massive reflected complicated surf zone called the Wedge, which is very famous. It's apparently very difficult to surf, and there is probably some sort of a competition every year where if you go and can stay surfing for the longest time on the strongest wave, you win some kind of a prize. Apparently there are people getting hurt and maybe even dying because this is such a strong waveform that it smacks people into the ground. So this is obviously a constructive interference between incoming wave and reflected wave. It's because of the angle of the jetty meeting the prevalent waves that are coming in. Okay, and with constructive interference, you can actually create dangerous plunging breakers. Remember, we said natural plunging breakers can be created by having topography that has a sudden jump or a very steep slope and so on. Here you are creating artificially by reflecting waves from man-made structures. Standing waves can be created in the same way when you have a narrow channel in which waves are going in and meeting the reflected waves, or you have like a lake, for example, where maybe you have waves. So two waves of the same wavelength moving in opposite directions can meet, and water particles are moving vertically and horizontally. Water is sloshing back and forth. But if you look at the structure, so here we can think of it as a nice container. Okay, so this is showing here at time 0, at quarter period, half a period, 3/4, and 1 period. T is the period here. So you can see that the standing wave is basically sloshing back and forth, and it has nodes where there is no vertical motion. It's kind of a pivot around which there is motion on this side and there's motion on this side, but the node remains almost fixed. Antinodes are alternating crests and troughs. Again, very idealized situation, but nonetheless you can imagine how it goes. You can find animations. So in this little container you have a node in the middle, and you have two antinodes. So the water sloshes this way and the node remains right there. So you have water moving all the way up, reaching its maximum point, pausing for a second, and then sloshing back, right? So you have at quarter period, the water has sloshed back, so you have maximum horizontal and vertical motion. So this side is sinking, this side is rising, so you have sinking, rising, and horizontal flow matching the balance. And it remains motionless and swings this way, reaches its maximum, has to reach 0 speed and then slosh back, right? It's going this way, stop, come back. So now you have the entire flow opposite. This is going down, this is going up, and water is flowing this way. So that's what happens in a standing wave. Very simple. We will see when we do tides that lakes can create standing waves that are called seiches in lakes. Depends on the configuration and the period of the wave and the resonance that can happen. And resonance is not the right word, but nonetheless we will see what that is.